Okay, here we are back in the shop. I got some new subscribers on the YouTube channel, and a bunch of them. I don't know, don't know where they came from, but I'm glad to see them come in. I'm glad they watch the videos and subscribe. It's always enjoyable to see the folks that come watch the videos. And I'm getting a little bit more used to working out how to get around there on YouTube. I never did really mess with it too much, other than just post a few videos when I started. But I started watching other people's videos and going to their channels, and it's really interesting. I got some great subscribers, and I try to subscribe to the ones that has a channel when they come, because I always enjoy watching their videos. But anyway, back to the task at hand here. I got some messages and some emails and a couple of comments on the YouTube channel about the little router that I made the inserts and things for, and also the router fence that I made to use on the Inca positioner. Got some questions and comments about that, so thought I'd try to cover them. One of the emails that I got was concerning the roundover bit that I used in this little router station here that I set up. It was just a dedicated piece. Let me get the camera on it here. I'm gonna move around here a little bit. Okay, it's a little old Craftsman. It's, I don't know, probably 10, 15 years old, something. I bought it long before I had the woodworking shop here. This actually was to do project. I was working on a job there, remodeling a house, and I didn't even have at that time a router table, so I ran to Sears and got me a little portable one that I could set up out there, and it served me well. It done well for what I wanted to do with it, and got that house finished out and all that. So anyway, I don't know, a lot of you know it, probably saw some of the toy parts where I've made in some of the videos there, but I'll make little small toy parts for a local company here in town that sells Appalachian toys. So when I make these little parts, they got to be rounded over. You can't have any sharp edges and that sort of thing. Don't want any of these young'uns getting hurt by them. So some of the parts are so thin and so small it's hard to get a round over edge on them with a machine. You know, either you'd have to take and sand it smooth or scrape it or something. But I've got this thing set up here, and it works really well. And what I did, this table started out, you just mounted your router in it. It didn't have a plate. Your router mounts right to the table. And it had a hole in it. I guess the hole was probably the size of the one in this insert right here. Well, on that particular job that I was working on, I'd had to do some door panels. So I wound up using a panel raising cutter on the router in this table. So it cut a bigger hole because I had to go down with it some. So it cut out a bigger area right here than it originally came from the factory. So when I decided I wanted to use this for this purpose, I took and I made me a jig. And I'll lay it right here. And it ain't nothing except it's just a piece of plywood with a hole in it. The size was just a little bit bigger than what that wing cutter had cut there in that table. Now I cut this out with a hole saw and a drill press. If you didn't have one of those, you could cut it out with a jigsaw and then sand it smooth. You just want the edges of it smooth, and you want it round. So it was much easier with a big hole saw and a drill press. But if you didn't have one, you could always use a jigsaw and cut it out and then sand it back smooth, file it the best, get it just as close to round as you possibly can. And then I took it and clamped it onto my table here and got it set just right around that hole, right each equal space around it. And then I took me a router and a straight cutting bit. The one I used was, I guess, a pattern bit. The bearing was on top of the thing, so I was able to stick it down in there, and the bearing rode on the plywood. And the cutter cut it out. And I took a router and I cut it out. And I cut it out to the depth of the insert that I was going to use. Now these are made out of MDF. You could make them out of anything, and it might be better to make them out of real wood. I used MDF because I had it, and I cut these on lay. I chucked them up in the lay, and I've got a piece for a duplicator that's got carbide bit on it. So I was able to cut the MDF with the carbide, never touch it with my lay tools. And then it started out as it was I think 1/2 inch thick. So I sawed it down some on the bandsaw. And then I used the drum sander to bring it down to the final thickness that I wanted it to go in here. So if you don't have a drum sander and a lay, and you're just getting started out, I'd recommend just using a solid piece of wood, or maybe just a piece of 1/4 inch plywood. A pretty good grade of 1/4 inch plywood. And then when you cut your hole here, only cut it as deep as whatever you're using. Of course, the thing here is about, I don't know, maybe 3/4 inch, 5/8 something. It's not all that thick, so you don't want to go too far. You can leave the existing hole that's in it, but you enlarge it for your insert to set down in there. But whatever, if you don't have any way of thinning it down and making it perfectly flat, so you need, if you start out with something that's about the thickness that you're going to use, like a 1/4 inch plywood, 5/16, whatever you can come up with. If you don't have the stuff to thin it down, so you need to start with it anyway, and cut your depth of your hole where it's about the same, or maybe just barely below. Now, if you get it cut out and you get your pieces made and you find out that they're not tight enough, unless it's a great big amount, if it's just a small amount, here's what I do. I take and I don't know where you can see that or not, but I take and rub a piece of masking tape around the edge of it, and then take a razor blade and trim it off. So that's just a little spacer. So that makes it go in there. If you're not perfect, it helps fill up the voids, and you may have to put 2 pieces. If you go much more than that, you probably just need to throw the insert away and start again. You don't want to put too much in it, but that's pretty thin. And if you get just the right amount on it without putting a whole lot, it'll be in there snug and it'll stay. And what I done on this one, I just cut a hole. It started out with a little I think I used a 1/4 inch to chuck it up on a lay. Now if you don't have a lay, if you want to cut these out with a hole saw, if you had that, if not, you're back with the jigsaw. Try to get them as round as possible, and then sand them good and smooth. But you want to make sure your hole's in the center. And what I did was bore a hole in the center that was the same size as this bearing, and then I mounted it in the table, and I just held it in place, and then I just raised the router up with it running, and it cut out the hole to where I've got a 0 clearance for this little 1/8 inch round over bit. And the 1/8 thing works great for the small pieces. Now I had to do just a little bit of a modifications to the bit. I'm going to try to show you that here. Now this is much bigger than a 1/8, but this is an old bit that I've got, a spare that I don't use anymore, and I just keep it for a spare. Let's see. Let me get a little pointer here so I can point that out. Okay. Now what we got right here. Let me get the camera around here. It's hard for me to see it. if you can see this lip on this bit right here, that's the stop for the bearing. See, if you put that bearing on there, now I know the diameter of this bearing is not correct for this bit, but that's not what I'm after to show you. Because the question was about the washer. Now these router bits normally come with a washer. It'd be under the bearing. The washer would be on it, and then the bearing will go on it, and then the screw that goes down through it. But when you do this, if your piece is really thin, that washer will leave it. It'll leave a little ridge in there. So what I did, and I don't recommend anybody do this, it's somewhat dangerous, so if you do it, it's all on you. But I took mine up in the lay. And right there where that shoulder is, it stopped that bearing from going on down. I took me a file. And while that was running in the lay, I brought the edge of that file right up here, and I filed that shoulder down to where it was the same size as this shank right here. Almost to the carbide. Now, I didn't take it plumb to the carbide. You've got to have a little bit of a shoulder. You don't want your bearing touching your carbide, but you want the bearing, the race on the outside of the bearing, to get down here just as close to that carbide as you can get it without touching. So I took a file while it was in the lay and filed this shoulder down to the same size as the shank right here, so the bearing would go on down. And then when I put it back together, I left that washer off. And when you look at the bit that's on the machine right here, and this was an experiment, so I went to the local big box store up there and bought the cheapest router bit they had, which was I believe it was a Skil. It was the least expensive 1/8 bit that they had, because I didn't know if you bump that carbide, well, that thing's in the lay. If you let anything touch that carbide, it'll bust it. It'll break it off. Carbide is extremely hard, and that means it's brittle. So if you touch it with anything with that carbide, with a file or something like that, and hit running in the lay, it'll more than likely break it off. So I figured that's what would happen. So I got an inexpensive bit, but anyway, it worked out great. I got it cut down there just right. I left that washer off and then put the bearing back on it. So now that gives me the ability to do a really thin piece without leaving that groove in there. Because if you got a thin piece and you got a big bearing like this, like it's supposed to be on it with a 1/8 bit, your piece will ride up above it if you're not careful, and it'll leave that groove in it where the bearing runs away from the carbide. But anyhow, that's how I did that to make this bit work for those little toy parts. It may sound complex for somebody that's never seen that done, and like I said, it's not something that I recommend you do, especially starting out. You might want to consider getting somebody to do it at the machine shop or something. The bit don't cost that much. If you damaged it, you could always get another one. But if you had it spinning in the lay and you broke a piece of that carbide off, it could potentially fly up and hit you in the face or in the eye or somewhere else, because it'll be brand new and it'll be sharp. I thought that this one wouldn't last very long because it was relatively inexpensive. I've cut many pieces on it, and it still cuts great. You have to keep an eye on it. You have to keep the shavings cleared out, and about every time I use it, I'll take the air hose and blow it out real good, and put a little drop of lubricant on it. Even though it's a sealed bearing, that's what that washer does on the bottom. It keeps it from pushing the dust up into that bearing. So a little bit gets in there. Take air hose and blow it out. Blow it off real good and keep it lubed, and it still turns good as it ever did. Eventually it'll have to be replaced, and I'll do the same thing. as long as this thing's been on here, and it's been on here a while, and I've made toy parts all summer long, right up here into Christmas, with this one cutter right here. I think it's like, I don't know, $10-12. So I've more than got the money's worth out of this cutter, and it still cuts great. I can, if nothing happens, I can probably use it for another year maybe. Because you're not taking much when you use these things. But anyway, that was the question on the router bit and how I made that work. Anybody that's ever used one, and I'm sure the fellow that sent me the email had run into that with some small parts because he wanted to know how I kept that ridge off of there. So I guess he'd been involved in the same thing. But the little router table, like I said, it's an inexpensive thing. Came from Sears. It's quite old. But I'm sure they still got some. I don't know. They're probably not made like this one. It's got a plastic fence on it. Sometimes I use the fence, sometimes I don't. If I need to come around and I work off the bearing. I like to keep it on there if possible though, because I keep my dust collector and hose hooked up to it. And it gets more dust than you think off a little bit, although it don't make a huge amount. The little cutter don't, but bring it up here pretty close when you can, and it gets a whole lot more of it. So talk just a little bit about the other router station. I got a couple of questions on it, and we'll talk about it a little bit. Okay, we're gonna talk about this fence on this router table that I built right here. I showed it in the shop tour, but I got an email with a fellow wanting to know just a little bit more about the fence system, and I think I mentioned there that I liked it really well, and I think maybe you might have been interested in one. So I'm going to twist it around here, and I'm sure that some of you seen these things and you may know all about it, and might be a little boring to those that do, but kind of bear with me here. I try to help anybody that I can. If they got any questions, they got a question about a piece of equipment or how it works or what I think about it, I try my best to answer. Sometimes it takes me a little while, but anyway, what I like about this Freud fence, Freud, however you want to pronounce it, it works just like the fence on my shaper. So these halves are independent. Of course, it's got a locking knob, and then you got your adjustment. They work really smooth, and they're really tight, and they're really fine adjustment. I don't know if you can see. I guess you can see that thing moving in the video, but and you can set these things independently. Now, if you don't have a joiner, and I'm sure there's quite a few people that don't, but they might need to join a couple of pieces of wood. This works really well. You take a straight cutting bit and put in your router, and you bring this fence up here, and you set these things up, and you can offset it however much you want to take off at a pass. You set this one right here to the same height as your cutter. Now this is a bullnose cutter I've got on here now. I was working on that cabinet project, but bring this one out and set it to the right straight even with the blade on your cutter, and then you can move this one back and forth and regulate how much you take off at a time. And you can use your router station as a joiner. There's all kinds of fences for router tables. Some of them is solid, some of them slides independently, and they use shims to move them out. All different kinds. You have to kind of look at them all and pick out what you like. I like the adjustability of this and the price. I mean, it's a good sturdy metal fence. Now I have replaced the wooden pieces on it. I think it came with some MDF pieces or something. So, but I took and cut me out some red oak ones and fixed them and put them back on here. They're just a little bit taller and a little bit longer, and they're a whole lot thicker. I think them it was on it was like 1/2 inch thick. Then I've got these at 3/4 of an inch, less flex, and I keep a look at them. If they get to where they get bowed, I can run across the joiner or the sander and flatten them right back out. But this wood's pretty stable. I made them out of. So, but the whole assembly moves. Of course, it's on slides. And then when I bored the holes and for the anchor knobs, I put 2 sets of holes in it, so you can change them out there. The whole assembly will slide. You can lock it down, and then you can move the halves in and out. Get them where you need them and line them up, make them perfectly straight. Or if you need them offset. When I originally started this thing, I didn't have a shaper. I got the tools in the shop. As the old Johnny Cash song goes, one piece at a time. So I used this table right here. This was the first piece that I built when I bought this place and got this building right here to start my shop. I had a little table saw, and a little miter saw. And anyway, this was the first piece that I built in this building. So it got a lot of use till I got bigger and got me a shaper. So if you had a tall molding bit in, you was making some crown molding or something, you might want to offset it. You might need a little offset for a piece of molding, and that worked out great. That's the reason for this setup instead of one solid fence. Now this is the homemade fence that they was asking me about. I told them I'd show. This just some plywood. I had some heavy duty plywood that somebody gave me one time. So this is 7/8 inch thick, I think it is. The frame of this thing is. But you can use 3/4. I used this because I had it, but it certainly wasn't necessary to make it out of 7/8. 3/4 would be fine. But just however high you want it, and some end pieces, and kind of frame it out. It's like this. And I put my 2 pieces in here in the middle to make it stronger, and then I just cut it where the dust collection hose goes right on it there. And this particular one, of course, you can see the bolts in it here. Now what that does is when you turn it around, you can slide those in this T-track, and you can have this fence attached to this anchor positioner. And I use that sometimes to do various things with a coping sled or whatever, and I had to ride along this fence. And then I've got T-slots cut into the wood here, and I can put hold downs on it and that sort of thing. And also I've got holes in the bottom of it here where it fits on the little Craftsman table if I need it to. I can take it over there and I can put it on it and have a good solid fence instead of the little cheap plastic one if I need to. And these side pieces here were just some scrap plywood that I had laying around. It looks funny like this because I'd run them through the drum sander to make them perfectly flat, and it took the veneer off. And I guess this is where they had filled it or something as they made the plywood. But they're perfectly flat now. So it's just a kind of a homemade thing, but it works really well with the anchor positioner. Of course, we went through it. This is one of the most precise pieces in the shop, and that's gonna take a video and all in its own. But going to be coming up and doing some boxes, I think, here, and using this to cut some dovetails and some finger joints and or box joints rather. So we'll show the setup on that and get into that when we do that. So anyway, I wanted to cover those things. Like I said, I'd had some requests about it, and I wanted to make sure that I got it covered. And a fellow was asking me, posted me about the lighting. I don't know how well that'll work out there. Just get a shot of the lights. They're just a 4-foot fluorescent. I got 4 bulbs to a fixture. 12 fixtures in the shop. It makes for pretty good lighting. I see it here fairly well, and of course you can see it in the videos. I got pretty good light. Once in a while, if you get off over in the corner, you might need a little more, or get up on one of the individual machines where it's something a little bit shaded. Of course, like the drill press and the bandsaw and scroll saw and that sort of stuff, they got their own little light with them, so that makes up for any deficiency there. But as a general rule, the lighting works well. I've got a 5 horsepower air compressor that's outside I've got building built on the front of the shop here where the dust collector is, and of course it's got some storage out there, and then I got a 5 horsepower air compressor out there. The fellow was asking me about that, and I've got one of those out there. Maybe when it warms up a little bit, I'll I'll do a thing on the dust collector and the compressor out there. Of course, it's just a standard thing. No, nothing. The dust collector is kind of a homemade thing that I rigged up. I got a pretty good dust blower attached to it, but the cyclone and stuff is it's one that's homemade, and I got double barrels under it, and with a homemade Y. Had one of the viewers who was talking about the tools, expensive tools, and we try to get good tools, but try to get them where they're affordable. Most of the time you get what you pay for, but there is a point where that just goes out the window. You can get in the woodworking world, there's everything from just absolute junk to great tools. The difference between a really good piece of equipment and a great one is several $1,000s, but sometimes I fail to see the benefit in spending that extra several $1,000s on that one particular piece. I know there's always things that can be better, but like I said in the shop tour video, you talk about a saw. If you can set your saw up where it cuts straight, it cuts smooth, it cuts good, and it has enough power to do it. Once you've made a cut like that, there ain't much way to improve it. The difference between a really good table saw, $1,100, $1,200, versus I guess would be called a great table saw, $2,500 to $3,000 to $3,500. When the board comes out the outfeed, if they're straight, true and square, I can't see the difference. But anyway, that's the way we look at those. So I hope that answers all the questions. Anybody's got any more, post them, and I'll be more than happy to answer. And one more thing, I will had a couple of inquiries about the display cabinet, and I will take a couple of shots of that when we get it installed up there and get it in place, and after it's completely finished, and let folks see that. So hope everybody had a Merry Christmas, and hope to have a great New Year. We'll see you next time. Thank you.